Okay, good morning. Today's date is April 15th, 2015. It is 11:05 a.m. and this webinar is 1 hour in length, and we're going to cover the newest innovation that we have put together in NeuroField regarding um, the combination of NeuroField pulse electromagnetic stimulation and Neuroguide um, 19-channel Loretto neurofeedback training. To say the least, I'm really excited about this stuff. Last week, we gave this little thing its send off at BrainThaw, and we saw some really neat stuff. So I'm going to share that with you today, and we're going to go over the procedure. Now, can everybody see my screen now? Somebody give me a text here or a response verbally or something. I get someone okay, yeah, okay, good. Now I do run my Loretto 19-channel neurofeedback, and I like to use the fusion technique. I like to use the symptom checklist, generate my protocol, and then go from there. It's a incredibly important I think conceptualization to be able to put the data together in a way that meets the person's needs, matches them, and really incorporates the best of what Neuroguide has to offer. Um, in my opinion, I've worked with both independently, and they both have their good points. But when you fuse the data together, I think you get an exponentially better product in terms of a protocol for a person. And that's my own clinical opinion, and I'm sticking to it. So unless that changes, you'll hear that soon. So what you're seeing before you now is the version 1005 of the LPR from Phil Jones and the protocol that I generated on Sophie here, who has volunteered her brain for the process of getting trained here today. So let me go back into the data here. This is the EEG that we just pulled, and I worked up the data prior to coming online here. And the last piece I realized that I did not work up was my symptom checklist match, so I need to do that. And let's go through the process really quickly about how I arrive at my treatment decision, and then we're going to run a neurofeedback session, and I'm going to show you how I run NeuroField and give stims as we go along. Now, for hooking up the equipment, if you're going to run NeuroField and Neuroguide together simultaneously, there are specific things that you have to have. We've posted this on the listserv, and I'm sure it's going to go into the manual. But just to keep it in mind right now, in order to do this, you have to have one stim unit and one Q20. That's the minimum requirements. Now, we're doing this today with 2 stim units and 1 Q20. You also have to have 2 CAN bus units that are connected to the computer. One of the CAN buses is to be connected directly and only to the Q20. The other CAN bus is to be connected to the computer and only to the stim unit. The mistake that people are making this week are they're connecting the stim units all together like they normally would in the past to the Q20, and that's not going to work. We're creating 2 independent platforms here for you to be able to operate the Q20 in Neuroguide and the stim unit in NeuroField. And in order to do that, they have to be physically separate. Now, if you run more than one stim unit, you have to link those 2 stim units together with a little RJ45 linker cable. And you plug the CAN bus into either of the stim units. And when NeuroField starts up, it will see the stim units. So those are the minimum requirements. It's very important that you that you set it up correctly. Otherwise, you're going to get errors. And of course, if you do have any issues, you can get on the listserv and ask us questions. Okay, with that said, let's go into our data here. I'm going to find Sophie's stuff, and here is her most recent map. And let me bring that up over here. It came up on the wrong screen. And what we're seeing here, Sophie wants to work on sleep and getting better sleep. And so we're going to focus on that today. In looking at her map, she has a pretty unremarkable map. She's low power in delta, and there's a little blip there in P3. When you look across all the power, you see a little blip of high beta in the back of her head. Relatively, this also comes out, which is why I like relative power, because relative power can show you the imbalances in the power spectrum and where the brain is high or low in something. And so I think it's incredibly important. You see some delta back here, which probably mitigates that to some degree, but there's definitely not enough delta in absolute power and too much high beta. So I want to see if we can influence that today. She's also a little low in alpha. Now remember that when you're looking at the summary page, this is an average, and the average is something that can distort the data, and so it is good to look at the single Hertz bins. Now before we go to that, we're looking at coherence here, and we see some hypocoherence in the frontal lobe and also in the temporal here. We also see some phase lag issues, and we see what looks like to be hypophase, or she's not firing long enough. This is really short communications from the front of her head to the back of her head in theta. And also we see that from T3 to T4, a real significant short communication from one temporal lobe to the other. We see distal relationships from the front of the head to the back of the head that are short firing. Now when I see this in phase, it's showing me, especially here in high beta, it's showing me rich club deregulations. Now remember, the rich club is a combination of the frontal superior and the posterior superior cingulate. And so we're looking at those major hubs and seeing how they're communicating. If those hubs are not communicating long enough, then it is difficult for the brain to be able to regulate itself. Another way of saying it is that if those hubs don't have call-outs that are long enough, then the brain amplitudes will remain at different levels in terms of microvolts. What we have found is that when phase shifts, then and it shifts long enough, then the brain automatically regulates itself, and you'll see power changes across the spectrum when you see phase changes. You'll also see coherence changes, which is one of the reasons why I've been stressing the cross-frequency coupling protocols, because we're looking for the rich club to communicate. We're looking for the system to communicate in such a way so that it can regulate itself. We certainly could jump to regular amplitude training, but if we do that without regulating the rich club, we limit the, I think, the total outcome of the training. You certainly can get outcomes. We have over the years before we started talking about this stuff, but I think we can enhance the outcomes when we have good rich club communications. In the newest release of NeuroField, which I released last night, there are some new articles in the documentation folder that you may want to read, talking about slow oscillations in the rich club. Very interesting article, which has led me to develop some new protocols that we're looking at. All right, so we see the summary sheet. Let's bounce over to the single Hertz bins. And in looking at, we see this delta deregulation here, slightly low, about 15 Hertz here in the back of the head, which is a bit high. And then when we get into the high beta ranges, we see the excess in high beta right over at O2, kind of stretching over to the rich club in PZ and O1. So there we have it. Let's take a look at the subcortical data. And first thing we're going to look at is Loretto data. And we see that the Loretto data is, it's really not that bad. But what we're seeing here is slight deregulations in the delta theta ranges. And again, 31, 32, this is posterior cingulate. 23 is posterior cingulate. 7, we're getting more to the frontal lobe. 5, motor strip on the left side, and you can see they're pretty slight. They're not too bad, which is a good thing, and we can probably regulate these and bring them up and get some better absolute power regulation here. Now, I like to look at this, but again, this is not a key variable for me. What is a key variable is the coherence in Loretto. This is where we're finding a lot of data that helps point us to which part of the rich club is deregulated. And when you're looking at the rich club, you really need to look at areas 9, 10, 13, 17, 18, 19, 23, 24, 29, 30, and 31. All those regions reflect the frontal and posterior cingulate, the visual cortex, the insula, the hippocampus. So these are all regions that I'm interested in. And so let's pop over to area 9, and we take a look here, and we see that there is hypercoherence in theta and alpha 1 in the back of the head, and the amygdala, the hippocampus. There's some deregulations here. We also see that in area 9 on the right side, we see some deregulations here in terms of hypercoherence. Hang on a second. We're going to... Brad is here making all sorts of noise, so I'm going to close him out. All right. So this is showing us some deregulations in area 9. I go up to 10, and again, we see some hypercoherence at 33, 46, 1, 2, and 3 in delta. And again, we have some alpha hypercoherence from the frontal lobe on the left side. And then we also see these hypocoherences in area 10. So 9 and 10 are the frontal portion of the rich club, and they are deregulated. And they're having issues in terms of communication with the posterior sides of the brain. So let's go over to 13, and again, we confirm more deregulations. We go to 17, 18, and 19, and we see hypocoherence on that right side where we saw that high beta, and at 19 as well. 23, posterior cingulate, again, deregulations to the visual cortex, and to the frontal lobes. Here's the anterior cingulate, and we do see, again, more deregulations. Again, when you start to do this again and again and again with people, you'll start to put together and conceptualize how these hubs are communicating. And so it's confirmed at this point that we have some deregulations. This is posterior cingulate. And again, we want to see this speaking to this visual cortex more efficiently, and it's not right now. And it's hypercoherent with other portions of the brain, especially motor cortex. Here's 30, posterior cingulate, and 31. So, you know, the Loretto coherence really does show you an enormous amount of data. If I flip to the end of this, and we get all the way, here's the amygdala. And we're seeing some hypercoherences here, a couple hypos, and the hippocampus. So to me, it would be very important to train these sites and really look at them. In terms of Neuroguide, one of the best symptom checklist items to look at is in the network selection. And I would look at either the default mode network and or the salience network. And I would look at fusing data into either of those. So I have enough information now to make my choices, and I'm going to move forward here, close this out, and I'm going to take you over to the Loretto progress report. Now let me close this down. So I generated all this data, and you can see here in the Loretto progress report, this is what the report actually looks like when I generated the FFT, the JTFA data, coherence and phase lock and phase shift. Because the Loretto progress report generates this data, it doesn't mean that you should use it. You should use it if it makes sense based on your analysis, based on the numbers that you saw in the Loretto coherence, in phase. I mean, all these things are very important, but it's very important that you look at all the data that you generated in Neuroguide, in Loretto, and from the surface, and from your clinical impression of the person before you start dropping in variables and metrics from this report. With that said, we know there's delta deficiencies, and we can see those at 37, 13, 29. All these make sense to me. The delta in JTFA is also showing deficiencies here. So I'm really liking what I'm seeing from these two rows of or columns of data. The coherences here are also important. Remember the rich club areas. You can start to match those to the data that it's generating and see how she responds. Now, before I start using this, what I'm going to do is I'm going to export that data to a PDF, and I'm going to call it, I don't think we actually have to name it there. Oh, there we go. Okay. So I'm going to save it, and it goes to her file. And yeah, we want to open it, and there it is. Okay, so we're going to hold this aside here. So when we look at the other data here, the Loretto progress report shows us deficiencies in delta at 19R. And that makes a lot of sense to me because that really matches the surface data that we saw. And it's also good because she has that excessive high beta on that side of her brain. So that's a big deal because the precuneus is part of the Rich Club, and these are significant deregulations. So we want to see if we can improve those. We want to see delta come up at 19R. When I look at the sort here, I like the symptom checklist individual selections, but I'm more network prone, especially lately with all the cross-frequency coupling that we're doing. I see it to be very important. And in looking at this, executive function is good, but that's really not going to go where I want to see it go in terms of the back of the head. We really do need to make sure we get to 17, 18, 19. The DTI network is a good one. This one can help us to make those connections from the front to the back and those distal relationships. So it's probably going to, if we use that as a symptom checklist item, that would target phase from areas 9 and 10 to 17, 18, and 19. That would also be very good. But you know, we're also seeing executive function again from mesolim. I'm not going to use that one again because it's going to omit the sites from the back of the head. And right here we do see the default mode network pops up. I'm interested in that as well, simply because that does represent the Rich Club significantly. It's only a 30% match, but it's going to pull 7 different areas. So I'm more prone to go to default mode network. Now, just for a little drill here, in looking at this this plot, we see that the average voxel, center voxel, and maximum voxels are all pretty close to each other. They're really not that far away. And so that really does suggest that we should be able to get some pretty good training out of Neuroguide, especially for the delta ranges where it's in the -3 range. I want to see that come up, which should really help to regulate her sleep. So with that said, let's move on into our training. Oh, not now. Okay. Now what I'm going to do here is I'm going to keep this open, and I want to zoom in a bit, and I'm going to keep it just like that so I can get to that data at a moment's notice. Now I'm going to run her using BrainSurfer so we can actually run and see what happens. Okay, so when you're opening up Neuroguide and NeuroField, it's important that you start in the correct order. We want to let Neuroguide find the Q20 and start up the Q20 first before we start NeuroField. So make sure that NeuroField is closed. Now I have Neuroguide open here. So the first thing I'm going to do is start the collection module. At this point, when you start up Neuroguide and you have data loaded, it's not looking for an amplifier until you click on collection and then set up and monitor. As soon as I click on that, it's going to say, do I want to save my EEG? I've already done that. But after that, what it does is it looks for the amplifier. And soon, if you see this screen right here where it's displaying this information, this means that it found the Q20 amplifier and has taken control of one of the drivers on one of the CAN bus units. We don't know which one it is yet, but it's grabbed one of them and is in control of it, which means that we're good to go. So I'm going to say OK. At this point, I can go back and open up NeuroField if I want to, but I'm not going to yet. So I'm just going to grab Sophie's file here. Where is she? There she is. Okay. And we're going to have her do this training eyes closed. All right. And I'm going to name it EC6. And I'm going to say OK. So now NeuroGuide's running away here. And we're good to go, letting NeuroGuide run. And I'm going to start shrinking stuff up here so that I can get as much real estate as possible. All right. So now when NeuroGuide's running, you confirm that you're getting a good EEG. I'm really happy. This is a good looking tracing. Everything's good to go. So what I can do at this point is go to Collection, BrainSurfer. And I'm going to open up BrainSurfer now. And I'm going to bring it over. I'm going to put the brain, actually I'm going to keep it on my screen. And she'll go with sound. And I'm going to set up her protocol. So one of the things I want to do now is I'm going to enable the sound and I'm going to make it a bell sound. People do different sounds. You can choose what you want. Then I'm going to click symptom checklist match and I'm going to grab her symptom checklist match and I'm going to load it. Then I'm going to go to networks and I'm going to go down to default mode. And it doesn't matter what number you put in here, 1 or 10, it's still going to get the same thing. And we're going to take a look and see what NeuroGuide will grab. You see 10 and 11, 9's not in there. We see 19, 29, 30, 31. Those are all really good matches. We see 35, 39, and 40. So a lot of good rich club selections here. But I want to add a couple of others. But I want to say OK now. I want to see how many metrics that NeuroGuide's going to grab. And it looks like it grabs 134 metrics. That's a good amount of metrics to train. And it's grabbing, I want to make sure that we get that high beta on the right side in there. So I'm going to add that to the mix. This is where you begin the fusion process. The delta theta is also very important in 10 here. Now I'm seeing, I want to see 9 get in there as well. So I'm going to add 9 right and left. And I'm going to put delta theta in there for both of them. And then I want to see 13. Let's see, 13 right and left. And I'm going to put delta theta on both of those. See, I feel comfortable with this simply because Z-score training, we're training towards a Z of 0. If these regions are not deregulated, they're going to train towards a Z of 0. If they're not deregulated, then you're still going to train towards a Z of 0. In either case, it's training towards the normative range. And then we've never seen any issues with this in terms of fusing this kind of data. So then I'm going to jump over to, here's 19, that's looking good. We could add 17 and 18 there. Let's see if we have, you're only allowed to put so many sites in here, so I'm a little concerned about putting too many, but we'll try 17. Up, we hit the limit. So if you hit the limit, what you do is try to run it the way it is, and if you can, great. If you see that certain sites don't have, are not deregulated, you can pull those out and start adding metrics as you go. Now our coherences here show a lot of rich club connectivity, especially from 10R to 19. This is important, and that's also going to do the same in phase. So this is really good. I'm liking that. Okay, so what we're going to do here is we're going to do, we'll do let's do 6-minute rounds. And there's a number of ways that you can do this. I'm going to do 5 minutes per round. I can put a delay of time in here and have NeuroField ready to go and give a stim. Or what I can do is put it on manual. Now when this happens, when we come to the end of the round, in order to start the next round, I have to go to the Session Rounds tab and click on Start Round if I do it this way. And that's the way I'm going to do it because I want to give her a stim that may be, at different lengths. And sometimes I don't know what that's going to be. I also like to talk to the person, so I want to see how they're feeling. So what I'm going to do now is we set up everything that we want to in Neuroguide. And the last step is to simply save the protocol. And I'm going to create a folder called Sessions, and this is where I'm going to keep her protocol. And I'm going to call it BrainSurfer protocol. And we'll save it. So now that's there. So the next time I train her, we can just pull up the protocol without having to create all this. All right, so let me see if there's anything here that's pressing. Okay, good. Looks like we're moving along nicely. All right, so now I'm going to, since I have all this rolling, I'm going to open up NeuroField. And I'm going to open up my cross-frequency coupling database, and then I'm going to click on Continue. Now, when you get to this screen, you have to click on the Query CAN bus. And it's going to look for the CAN buses that are available. And if you look at this, what you're seeing is 2 X3000s are available on CAN bus adapter number 2. And nothing was seen as being available on CAN bus adapter number 1 because Neuroguide owns that driver right now. And as you can see, you can't click on CAN bus number 1 because there's nothing to grab there. You'll also see there is an initialize error. Don't let that concern you. It just means that when NeuroField tried to grab the driver, Neuroguide said, nope, I already have that one. You can't have it. And so NeuroField generates this error, which is not a problem. All right, so now we see that we have 2 X3000s. I'm going to grab the CAN bus number 2. And of course, you want to save your data. You should always say yes. I just said no, but you don't want to listen to me. And then we're going to find Sophie in here. Hopefully she has there's her protocol. Okay, good. So now what we're going to do is we're going to pick a protocol for her. Now, there's different things that you can try because the CFC database is growing quite a bit. If a person has insomnia, one of the things that we have seen that works very nicely is a protocol that goes through 1 to 15 hertz and couples 80 to 150 of gamma, which is high gamma. We've also tried it in the lower frequency ranges from 1 to 15 with 40 to 80 hertz of gamma. Both of those work very well with people that have sleep problems. We have seen people regulate very quickly. And if you look at the protocol, I'm going to choose the 1 to 15, 40 to 80. One pass of this protocol takes 4 minutes. It's a long time. And so what we want to do here is I'm going to change it so that it's sweeping only at 1 second stims. and you'll see pretty rapid stimulations here. So, and this is for the purpose of this demonstration. Sometimes I would just leave it to run a couple of minutes on a person and then resume training. But for the purpose of this demo, I'm going to shorten the amount of stims, or the duration of the stim. Okay, so now I've selected my protocol, I selected my patient, I'm ready to go. I'm going to minimize NeuroField so we can see everything run on the screen at the same time, which makes it kind of fun. And then we're going to minimize Neuroguide and put that down here so we can see everything run all at the same time, and it's neurofeedback glory. All right, so what we're going to do here is we're going to start the session by giving her a stim and then showing you what that actually looks like. So let's see if I actually make this data a little bit bigger so you can see it. It'll be useful for you. Now you can switch back and forth between each program. Simply just click on each one and you'll bring it to the focus, and then you can start it. So we're going to start a stim with NeuroField, and here we go. And there's the stim. Now as you watch it on the scope, it looks all muddy, but what you're actually seeing is the cross-frequency coupling. It's hard to see when the microvolt scale is only set to 50. So what you need to do is bring it back a bit and zoom out. I'm going to change it to 150, and now you can actually watch it, and you can see these gamma oscillations. You can also see the slow frequency stimulation occurring at the same time. And what's really interesting here is that the brain will respond to each one of the stims differently. And if you look at NeuroField here, you see that we're giving 1 hertz stimulations, and we're pairing gamma to it. Now it's going to 2 hertz. And you can see the oscillations occur. And you can see the fast frequency that's coupled to it. Now the only reason that this can happen is because we're phase matching and amplitude matching each frequency with the high gamma harmonic. And it's an exact phase match, which is really cool. And the amplitude's the same, even though her brain may respond to it differently. Here you'll see different responses to different frequencies. I think that there's a lot to be said about that. We can see you know, how the brain responds to 5 hertz versus 10 hertz versus 15 hertz. And I think we're going to learn a lot about what that actually means as time goes on. So with her first stim here, I am skewing the outcome of the session somewhat by not starting BrainSurfer. I want to give her brain a little bit of priming here. I want to get it on board with what I want to do in terms of the training. That's a really interesting oscillation there. We're at 9 hertz now. And we're moving through each one of the frequency bends now. The faster the frequency, the quicker you move through the gamma range, because it's going to jump by multiples of the frequency. So at 13 hertz, it's going to make 13 hertz jumps from 40 to 80 hertz because it has to stay harmonically matched. And we're at 15 now, and now it's done. Okay, so now what I'm going to do here is I'm going to start her training. And you give the person the instructions that when they hear the bell, they are going to know that their brain is doing what they're supposed to do. I always tell people, get out of your own way. Simply let yourself train, and don't try to push the river, so to speak. So I'm going to start the training here. And we're going to go to progress, and we're going to see where she is right now. Now remember, we saw some deregulations in terms of power and high beta, and we see that the z-score now is set to 1.5, which is probably too high here. She's getting pretty consistent hits, and she's scoring quite a bit here. So what I'm going to do here is I'm going to challenge her a little bit and bring it down to about 1.3. And we'll apply that. And we want to get we want to make the training just a bit more challenging. And let's bring it down again to 1.2. And we can watch BrainSurfer light up here as we make it more difficult. And you can see where the z-scores are right now. They're resting at about 1.5. Yeah, let's bring it down one more. It takes 10 seconds for Neuroguide to recalculate the slope of the z-score. And once it does that, then it will start to give rewards again. So as you can tell here, I'm reducing her percentage reward significantly by making the z-score go down. And you can see it in BrainSurfer when you see things light up here, you can see where the deregulations are. And let's make it even more difficult. I'll bring it down to 1 into the normative range. And you can see where those coherences are. Those really do appear to be an issue here because in terms of power, she's looking pretty good. So we're going to watch and see. And again, I would expect that Rich Club from the frontal to the occipital to have some issues. Okay, now this is adequately challenging. So now what I'm going to do here is she's coming up on the 3-minute mark. And what I'm going to do from minute 4 to 5 is I'm going to give her a stim. And we will bring that over here. And we're going to start it now. And watch what happens with BrainSurfer. So there's a couple of things that you're going to notice. The hubs all light up. And this is really interesting. Of course, the stimulation is going to change the numbers. But Neuroguide is set right now with a 40 hertz low pass filter, which means that it's ignoring the numbers above 40 hertz. And so all the gamma that we're putting in there is being ignored. Now we can look at these numbers here, and you can see how the stimulation does influence the training. So when a person is training like this, I would not want them to be. I would tell them that I'm giving them the stim so they know, and then I would let them know when it stops. So we're 3 to 4 minutes. She's just had about 1 minute of stim. I'm going to abort it, and now we're going to return to training. And let's see what happens. Now each time that we do this, you'll see the system respond. And you can choose to do stims minute on, a minute off. You could choose to do 5 minutes of training and then do the stims in between each round. We've been trying all sorts of different combinations. And depending on the person, with some of them it works very nicely. With others, you really do have to try some different combos to see what actually facilitates the training more so. Okay, so from minute 4 to 5, you saw me give her a stim, and you can see here in the training where that's influenced the data. Overall, though, we're seeing that her data is remaining pretty consistent. If we look at the session rounds, we can go over and start looking at what's happening with the z-scores. So what I'm going to do here now is I'm going to push her a bit with NeuroField, and we're going to give her another stim. And I want to give her about 2 minutes of stim, and then we'll go into the next round. Now, because I have everything paused, we can simply start the round when we're ready to go. This is a cleaner way of being able to run the training, simply because if you want to look at pure data, you really don't want the stim on. Now, I'm watching it with the stim on because I like to see what the brain does in real time. So when I'll do a minute or on or off during the training, you can choose to do 2 minutes of training, then 2 minutes of stim. Really doesn't matter. Try different combinations and see what works. We're seeing some really good responses with people when we do minute on or minute off. We also see good responses with people when we do a 5-minute round and then we do a 5-minute stim. Everybody's different. For some people, they do require more of a stim in order to get the brain to respond. For other people, less is more. Just a little bit of a stim goes a long way. A minute or two of priming the system, and as you can see, this brain is responding, which is really good. And I've been asked the question, how do you know? How do you know this just isn't noise? Well, here's one of the things. NeuroField can create square waves, sine waves, and triangle waves. What you're seeing here these are not square waves. These are sine waves. And right now, NeuroField is giving square waves. And so what we're seeing here is the brain is actually copying and replicating what we're putting into it. And it's creating the cross-frequency coupling in real time. It's following along with NeuroField, which is what we've always said about what the system does. So if it was just NeuroField by itself, you would see big square waves on the screen, and not a combination of these cross-frequency coupled waveforms, which are sine waves here. This is what you're actually seeing. So we're about 2 minutes and 32 seconds. So what I'm going to do is I'm going to abort that, and let's bring Neuroguide back online. And again, we're going to start stimming again and see what the system is doing now. And we are getting an increase in the rewards. They are increasing. She's doing well. As we look at our phase and coherence data, that was quite deregulated. It's really coming across nicely. And this is where I love to watch the progress tab here, because really you can see the numbers roll in real time and see where they are. And many of these are coming in the normative range. Now, one of the things you can do is that if numbers consistently come in this range, you can choose to pull them out and start to add JTFA data and start to fuse the protocol in such a way so as to get a better effect. Now she's coming down here a bit, which is interesting. So what I'm going to do is I want to facilitate a little bit more movement here. Unfortunately, what I just realized is that she can't hear the The reward, yeah, it's coming through my headphones. That's interesting. All right. Well, let's see if we can change that. I'm going to change it so we're doing this way. And let's try to bump the system there. I'm going to change it now to a delta high gamma. Let's see, delta high gamma. And let's do this for a minute 45 and see how it influences things. As the system runs, we'll let it go. And you can see that as the stems go, there are times where it's obviously decreasing the reward percentage. So that data wouldn't be valid in terms of just training somebody. But the idea is to use the CFC as a priming effect. And you can see in the scope how the brain is following it. And we're seeing different responses from different parts of the brain. Okay, here we go. And we're going to stop it and go back into the training. And let's see what happens. And you can watch as the system regulates itself. You get the basic idea in terms of how to actually set it up and how to run it. The real trick is what protocol to choose. We have found that the SMR Gamma protocol helps to bring up alpha. So if a person has low alpha, you can definitely bring it up using the SMR low gamma protocol. The delta gamma, alpha gamma, or the theta gamma, alpha gamma protocols are good for people that have anxiety. And so we do see improvements with people that are very anxious with those two protocols. The 1 to 15, 80 to 150 protocol seems to be very good for people that have sleep problems and insomnia. Okay, now I've skewed the data here by giving her stems as you're going along, but you can see that the system actually is regulated. It's responding nicely. Okay, I see one message. Okay. Okay, I see some questions here. So with Jill, where are the coils at right now? We have coils placed at the Rich Club at area 10, so F3, F4 basically, a little bit closer to FC. We have one set at PZ and one at OZ right now. And Ken Diaz says, what was it about the delta high gamma that made you choose it? Again, I like the delta gamma, delta high gamma for people with anxiety. And usually, if there are issues with sleep, it's one that you can choose. How is this different from RTZ? This is different from RTZ in that we're using Loretto, which allows us to target Brodmann areas in the subcortical range. RTZ targets areas on the surface of the cortex, so it's very good for power, phase, and surface cortical training. Also, the RTZ allows you to set up all the stuff that you just set up here in Loretto, but for surface sites. And you can use the cross-frequency coupling protocols with RTZ, and it's very powerful. But the difference is that with RTZ, you're training the surface versus training a subcortical like we're doing now. All right, so another protocol to try would be to we could go into, let's see, the SMR Gamma, and let's give a couple loops of that because that's only 14 seconds long there. Let's give 1 minute of it, and I want to select that and start it. And here comes SMR Gamma. Now we are paused in between rounds here, so it will not train until we restart it. And again, SMR Gamma is really good for bringing up alpha. For anxiety, I like the theta gamma, alpha gamma, with the theta gamma coils placed at FZ and the alpha gamma coils placed at PZ, or delta gamma, alpha gamma, same coil placements. If you're running the octopus, I also like to place the coils at T3, T4, or T5, T6. Really depends on where the Loretto the Loretto coherence map is showing us deregulations. Okay, so there we got 1 minute of SMR, and let's stop that right now. Okay, good. And we'll go back into our training. So I'm going to go back over here, and I'm going to start the round. And here we go. And we want to see what the SMR Gamma does. And you can see that the system now is really changing. It's much more variable, and that's a good thing because the brain knows how to calibrate itself better than anything out there. And a person can train very well if they're if we can get the system moving, so to speak. Unfortunately, right now, she can't hear the reward tone, so everything I've been doing now has been from my perspective. She's simply sitting still and receiving the stems. So this is a reflection of what happens in some ways with stem only. But when a person is training, what you're going to see is you're going to see some pretty fast regulations. They have to be able to receive the reward. So the feedback loop is not closed right now. It has not been closed the entire time. So what you're seeing really is how BrainSurfer depicts what the stem actually does. And what we're seeing now is we're seeing coherence variability. But if you look at the actual nodes here, you'll see that they're fairly well regulated. They're not too elevated right now. You know, in the close to the 1 z-score range, almost down the line, which is very good. Okay, I know that there's a lot here, and I know that we did it very quickly. I did record this so that once I crunch that data later today, I'll put it up on the listserv for you to be able to see. I'm also probably going to do a video where we just do live training and have a person train so you can actually see the training effect. But if you replicate this model, you should be able to see the training effect in your office. So please post what you find on the listserv. Let us know what you feel works and what doesn't work, and we can go from there. Are there any other questions before I stop? I don't see any. Okay. With that said, I hope you guys have a great day,